In this video, we are going to be taking a look at two different kinds of statistics that researchers use to look at associations between pairs of variables. So we're going to use this example to think about the information that is provided by these different statistics and what we can learn from them. The data that we are going to take a look at is called Older and Wiser: Associations Among Grade Level, Math Experience, and SAT Scores Among High School Students. So the research question in this data is, does high school student math achievement increase over time? So to answer this research question, we are going to take a look at data from our participants who are high school students. So we're going to be looking at a data set from 80 high school students. These high school students are in grades 9 through 12, and they are evenly distributed across the 4 different class years. So we have 20 freshmen, 20 sophomores, 20 juniors, and 20 seniors. And in this data set, we have SAT scores from the end of the academic year. So because our research question is focused on math achievement, we are going to be focusing on the students' SAT math scores. SAT math scores can range from between 200 and 800, and the average score in the United States on the SAT math is a 521. So to answer our question about whether students' math accomplishment increases over time over the course of high school, we're going to start by looking at the association between grade and the students' SAT math scores. So here I've created a scatter plot with our x-axis showing students' grade level, so increasing over time. And on our y-axis, we've got SAT math scores from a low of 200 up to the highest score that they can get, a score of 800. And here I have superimposed a graphical representation of the correlation between students' grade level and their SAT math score. A correlation is a numeric representation of the association between two variables. The correlation has two components. One important component is the sign of the correlation, and that tells you the direction of the association. A positive sign, so a correlation greater than 1, means that as one variable increases, the other variable also increases. A negative correlation we also call an inverse correlation, and that means that the association has a negative slope, or as one variable increases, the other variable decreases. So the correlation between grade level and SAT math scores in our high school students is positive 0.57. So this means that as grade level is increasing, we are observing corresponding increases in SAT math scores. The other important component of a correlation coefficient is the magnitude of the correlation. Correlation coefficients can range from -1 to +1, and the closer the value is to 1 or -1, the stronger that association is. So a correlation of -1 or +1 means that two variables are perfectly correlated. If you graphed them, it would create a straight line, and it also means that if you know the value of one variable, you can, with 100% accuracy, predict the value of the other variable. So an example of two variables that are perfectly correlated would be your height in inches and your height in centimeters. There is an exact correspondence between those two values. So in the case of our correlation between grade level and SAT math score, our correlation is kind of right around the middle of that hypothetical range. So a correlation of 0.57 is a medium or moderate positive correlation. And this was a statistically significant correlation. So students in higher grades are earning higher SAT math scores. So if we were going to interpret this in relation to our research question, we might think that as students progress through high school, that their math abilities are increasing, that going from 9th grade to 10th grade to 11th grade to 12th grade, that students are getting better at math as they get older. But there's another characteristic of our students that's going to be really important for us to consider as we think about this research question. And that is that these students are doing different things during their different years in school. So in this table, I'm showing you information about the average number of math classes that have been completed by the students in the different grades. And you can see that on average, students are completing more math classes the farther they get in school. So the average 9th grader has completed just about 1 math class. By 10th grade, an average of just over 2. 11th graders on average have taken 3 math classes, and seniors by the end of senior year have taken an average of 4 math classes. And if we look at the specific number of math classes that all of our students have taken, 3/4 of our 9th graders have only taken 1 math class. We've got 4 students who have taken 2 math classes and 1 student who's taken 3 math classes, but none of our freshmen have taken more than 3 math classes. When we get to 10th grade, we have 3 students who have only taken 1 math class, and the majority of our 10th graders have taken 2 math classes. We have 2 students in the 10th grade who have taken 3 math classes, and now we also have 2 students who have taken 4 math classes. We're getting even more variability when we look at our 11th graders. So we still have 1 student who has only completed 1 math class. 3 of our juniors have only taken 2 math classes. More than half of our 11th graders have taken 3 math classes. 2 of our students have taken 4 math classes, and now we have 2 more students who have taken 5 math classes. And then in the 12th grade, we can see that all of our students have taken at least 2 math classes, so 4 of them have only taken 2. Another 2 students have taken 3 math classes. 9 of our students have taken 4 math classes. 3 students have taken 5 math classes, and 2 students have taken 6 math classes. So if we want to think about how students' math abilities are changing over the course of high school, we can't just think about progression through time, but we also need to think about how their grade is related to the number of math classes that they've completed. So if we graph the association between the number of math classes that they have taken on our x-axis and their SAT math score on the y-axis, we also see another positive correlation here. So again, the sign of this correlation is positive. So as the number of math classes is increasing, the average SAT score is also increasing. And the magnitude of this correlation is stronger than we saw for grade level. So this correlation of 0.73 is closer to 1, meaning that this is a stronger association between the number of math classes that students have taken and their score on the math section of the SAT. So this brings us to 2 different ways that we can think about how pairs of variables are related to one another. In this graph, I have taken the same data that we looked at in the first figure, but I have broken up our students in these different grade levels based on the number of math classes that they have taken. So you can see that among our 9th graders, most of our students have only taken 1 math class. We have more students who have taken 1 or 2 classes when we look at our sophomores, a lot of students who have taken 3 classes or more when we look at our juniors, a lot of students who have taken 4 or more classes when we look at our seniors. So one way that we can think about the association between grade level and SAT math scores is the first approach that we took. So remember that our correlation between grade level and SAT math scores was a moderate positive correlation, a significant correlation of 0.57. But in the case of these high school students, this correlation might be misleading because we know that the grade that they're in is not the only difference among these students. So in this figure, rather than showing one line for all of our students, what I've done is I have broken these groups up based on the number of math classes that they have taken. And you can see that when we look just at students who have taken the same number of math classes, that we no longer see that positive association between grade and SAT math scores. So if we are only looking at students who have taken an average of 2 math classes, we are not seeing differences between 9th graders who have taken 2 math classes, 10th graders who have taken 2 math classes, 11th graders and 12th graders who have taken 2 math classes. If we look at students who have taken 4 math classes, we're not seeing differences between 10th graders who have taken 4 math classes, 11th graders who have taken 4 math classes, and seniors who have taken 4 math classes. So a statistical approach that we can use to take this into account is something called a multiple regression. In a multiple regression, we are looking at the association between 2 variables, controlling for other variables. When we use multiple regression, instead of a correlation coefficient, we get a statistic called a regression weight. You will commonly see this abbreviated with the Greek letter beta, and we can interpret this similarly to how we interpret a correlation coefficient in terms of the sign. So a positive regression coefficient means that as one variable increases, the other variable increases. And a negative regression weight means that as one variable increases, the other variable decreases. Now, regression weights can be larger than 1 or less than -1, but in the same way that the magnitude of a correlation coefficient indicates the strength of the association, the magnitude of a regression weight also tells us how strong the relationship is between two variables. So a larger regression weight means that two variables are more closely related to one another in comparison to another variable with a smaller regression weight. And our regression weights tell us about the association between two variables, controlling for any other variables that we have included in our analysis. So in this slide, I am showing you the regression weight from a multiple regression where I am predicting students' SAT math scores based on their grade level after controlling for the number of math classes that they have completed. So the regression weight for grade level in this analysis is 0.10. And that was not statistically significant. So there is not a significant association between grade level and SAT math scores once we take into account how many math classes our students have completed. So if we come back to our original research question, thinking about whether students' math achievement changes over time, we can see that students on average tend to have higher scores on the SAT math section in higher grades compared to lower grades, but that this isn't because they are getting older, it's not just because they're in higher grades, that it is explained by the number of math classes that they have taken. That as students go from 9th to 10th to 11th to 12th grades, that they tend to complete more math classes, and that completing more math classes is strongly associated with getting higher scores on the math section of the SAT. So this is an example of two different ways that you can look at how two different variables are associated with one another, and the different information that these two different statistics can provide us about how those pairs of variables are related to one another.